Okay, so continuing on talking about our different functional groups of mass spec, this video is going to be amines. Now, the only type of fragmentation that we are discussing with the amines is the alpha cleavage or our homolytic cleavage here. All right, so I have at least 3 videos at this point talking about that. That would be your alkyl chlorides, your ethers, your alcohols. So here's a 4th one with our amines. Now, you are going to do the exact same thing we've done in the other 3 videos. We're going to start with that radical electron. I don't care if it's nitrogen. It's still going to do the exact same thing. In this example, we're using triethylamine, so this is the example from your textbook. If you're my student, I told you it's super boring because it doesn't matter which ethyl group I pick. It's all the same ethyl group, so I'll get the same exact fragmentation. So therefore, I only have to do this once. But if these carbon groups were all different, you would have to do this 3 times to make sure you're representing all 3 fragmentations of the amine. All right, so let's get started. So we're going to form that double bond right here, or begin that process. We'll finish by breaking the carbon-carbon bond, and we're going to put that other electron from the carbon-carbon bond on that carbon connected to the alpha. All right, so yes, with the amines, the alpha position will still be the carbon attached to the nitrogen. Now, what we're going to form is we have our nitrogen. It still has the other 2 ethyl groups, but now it is double bonded to that 1 carbon, and then I formed my methyl radical. Once again, I have skipped the step where I was supposed to check the mass of my molecular ion, so let's do that. So my molecular ion is just going to be the mass of this entire thing. Molecular ion. So mass to charge ratio. All right, so nitrogen is 14 plus, I have 1, 2, I should have 6. I have 6 carbons, so 6 times 12 is still going to be 72. Now my hydrogens, I have, let's see, 3, 6, 9, 11, 13, I'm getting 15. Okay, so 15, so let's see. 14 plus 15 plus 72, I'm getting 101. So I should have a molecular ion peak of 101. Now, that nitrogen here better have a positive charge because I have 4 lines going to nitrogen. Therefore, that will be the fragment my mass spec sees. So since I lost a methyl group, I know what the mass of methyl is. So I can just say 101 minus 15 here. So I would expect this fragment to have a molecular or a mass to charge ratio of 86. So these would be the 2 peaks that I would look for in this amine. So let's take a look at that. All right, so I have 101, so that is my molecular ion peak. And then look, I still have my 86. Okay, good, I did that right. All right, so that is going to be my alpha cleavage. So I have sufficient data to support the idea that this is going to be my amine. And then don't forget, with our amines, if you have an odd number for that molecular ion peak, that is a hint that you have an odd number of nitrogens. But don't think an even number tells you that you don't have any. An even number just means you could have an even number of nitrogens. All right, so hopefully that was helpful with our amines.